Okay, in this video I'm going to attempt to explain the difference between seeing objects at a distance on a flat plane versus seeing objects at a distance that are on the surface of a sphere. This topic comes up time and time again when debating flat earth topics, and there's a lot of video evidence and people will show it going either way, either to prove flat earth or to disprove flat earth. And there are a lot of different theories or ideas to come up how to explain it to. So this is just basically going strictly from geometry and trigonometry and just the basics, not even really specifically talking about whether the earth is flat or not. It's just one example is going to be showing it on a flat plane, and another one is going to be showing it on the surface of a sphere, and you can see the differences and similarities for yourself. So first, I want to show that what I'm going to be demonstrating this with is a program called Blender. I've done another video about a flat earth concept, and I used the program for that as well because it's very good with showing, again, different viewpoints or different views or different camera angles. You can see the different objects and surfaces here, like a plane. So one of the things I did was I made a cube, a flat plane, and a small camera. Now I kept the camera small so that when I'm using the sphere, the difference between the camera and the sphere is going to be about 1,000 times different. So the sphere is going to be about 1,000 times bigger than the camera, just to show that on a large sphere the apparent horizon is very close to straight, and if you get big enough sphere from a perspective of something small on top of that surface of the sphere, that the horizon line will be straight. But I'll show that later in the video. But right now in this first part we have, again, the camera which is set up in front of the cube. Here I can kind of rotate it around and show you what it looks like. And this is actually the camera's view pointing at the cube. And I basically have an animation set up where the camera is going to move away from the cube at a pretty much constant height from the top of the plane. And you'll see the view here change from perspective of the camera. So if I move this and scrub along the video, you can see that on the top here that the camera is moving from left to right, and you can see that the picture, you can see from the camera's view, you can see it moving away, and it's getting further and further. Now to the observer it looks like the cube is getting smaller, but you can still see the entire cube. And I basically made the red stripe on the bottom. It's roughly the bottom third of the cube, so you can see that this whole time as the camera is moving away, you're able to see the entire cube, the blue part and the bottom red part. As you're going further and further away, you can still see the entire cube, which just looks from the camera's perspective to be getting smaller. Now at this point here, what I did was I'm going to stop moving the camera away, and I'm just going to change the focal length, which could be shown up here. In the program you could change the focal length of the camera, and basically what that does is performs a zoom. So with a regular camera, if you go from a 35 to a 70mm lens on, say, a DSLR camera, you're basically doing a 2x zoom. So if you have a camera lens that's 35 to 70mm, that's basically a 2x zoom. And if you go up another 35mm to 105mm, that's the equivalent of a 3x zoom. So what will be happening here first is I'm going to be zooming in to 2x, and we can see that now it's basically the same as moving forward closer to the object. And you can see that the square looks like it's getting bigger, but again you can still see the entire thing. And then I'm going to zoom in to 105, which is like a 3x zoom, and just from perspective it's getting bigger, but it looks, you can still see the entire cube. And then I'm going to zoom back out again. The camera's in the same spot, and then what I'm going to do is raise the camera up. So if you see on the top here, the camera is now moving up off the top of the plane. And so you still see the full front of the cube. Now maybe you can see the top because you're going above the cube. But that's what happens when you move up and down. But this entire time, from zooming in to moving back and everything, you can see the entire cube from top to bottom. Now I'll pull up basically the same setup of a cube, this time on a large sphere, and the size of the sphere again is about 1,000 times larger than the camera. Size of the sphere. So I come down here and go to sphere, and then go up here to scale. You see the scale, I made it 100 times its original size when it's created in Blender. And then with the camera, I did the opposite. I made the camera 1/10 the size it normally is in Blender, so that the scale between the two is about 1,000 times. Which, now if you're talking about the Earth to a person, that's way off. That's, I don't know the exact number, but probably at least 1,000 times off. So if you see here, at the horizon, it's got a slight curve to it, but again, if the sphere here was larger, then the horizon would appear to be even flatter. And I actually have a video that shows that, which I'm going to be uploading soon on a much larger sphere. But I just wanted, for this experiment, these dimensions, go over the general concept of, again, seeing an object from a distance on the surface of a sphere. So again, I'm going to be pulling the camera back, and you see the object moves away. But then if you get to a certain distance, if you look at the bottom of the cube here from the camera's perspective, you can see that the amount of red is going away, and the cube seems to be actually going down, even though the cube is staying stationary. And the camera's moving away, but you can see that it is now dipping below the horizon, so you can no longer see the red, and also the blue is starting to disappear, so you can just see a little sliver on the top. Now you could probably surmise from just viewing up top here why that is that the curvature here, as you can see, is blocking you from seeing the bottom part of the cube. And if I draw a line, a straight line from the camera, if you watch here, once the line intersects the surface, you're only able to see the very top part, because if you try to look any further down, all you're going to see is the ground here, or the surface of the sphere here, and you won't be able to see below this line on the cube, which is exactly what you're seeing here. And then again, here, I'm again zooming in with the camera in Blender, and you can see that it's getting bigger, but you're still just seeing the top of the blue. You're not seeing any of the red. And that's a 2x zoom, and then moving into 3x, and still just a part of the cube that you're seeing from a distance is still there, but you're not seeing any more of the cube. You're not seeing any of the red. But if I zoom out and then move the camera up again, like I did in the first example, more and more of the cube is revealed, because you're rising above the surface of the sphere, and you're able to see. And you're able to see past the curve. So if I draw another line from the front of the camera to the cube, you can see that you pretty much can see the entire cube now, because the curvature of the sphere is no longer blocking your line of sight. So that's just the basics, just using a program that just is basically modeling geometry. It's modeling a sphere, it's modeling a plane, cube. It's using a camera that's pretty physically accurate. It's used for doing animation, both photorealistic and cartoon animations. But the principles apply, and so basically shows two differences and why what we see in videos online with, say, boats disappearing bottom first over the horizon, that would occur because of the surface being curved, because we're on a very large sphere and not on a flat plane, which the entire object from a distance can still be seen. It just gets smaller to our perspective. So hopefully you found this helpful. If you have any questions or comments, I can leave them below, and I'll be happy to answer them. And if you need any further clarification, Again, I will be making another video about horizons and how they appear flat on a very large sphere, and I'll be uploading that soon.